Well, hi students, this is a integrity video on roots and radicals. And this is 7.2, and the first thing I needed to remind you to do is to make sure that you are familiar with the perfect squares. Definitely be familiar with the first 10 perfect squares. The perfect squares are here in purple: 1, for example, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. And the reason why they are perfect squares is because you can take a number and square it and get that number. Okay, so for example, 1 squared is 1, 2 squared is 4, 3 squared is 9. So it's important that you know that when you see these numbers 1, 4, 9, 16, etc., you know that you can find the perfect square, the square root of that perfect square. The square root symbol looks like, alright, the square root symbol is this little symbol here. If there is no number here for the index, that means that it's considered to be a 2, not a 1. So the word square root, squaring, for example, that word is considered to be 2. So the square root of 1 is 1, since 1 squared is 1. Square root of 4 is 2, since 2 squared is 4. Square root of 9 is 3, since 3 squared equals 9. So that's how you find the square root. You find that number that's being squared to get that number under that radical symbol. Here are some perfect cubes. 1 is a perfect cube also because 1 times 1 times 1 is 1. 8 is a perfect cube because 2 cubed is 8. 27 is a perfect cube because 3 cubed is 27, and so on. So be familiar with the numbers 1, 8, 27, 64, and 125 especially. The cube root symbol looks like this. So as you can see, there is a 3. The 3 is the index. So if you're trying to find the cube root of 1, that equals 1 because 1 cubed is 1. Or you're trying to find the cube root of 8. 8 is a perfect cube. What number times itself is 8? 2, since 2 times 2 times 2 is 8. Or what is the cube root of 27? It's 3 because 3 times 3 times 3 is 27, and so on. So be familiar with the numbers 1, 8, 27, 64, 125 especially. And you can use your calculator, of course, so it will help you once you get the test just to write down all the perfect cubes, write down all the perfect squares, so that you can have it readily available to look at when you're trying to figure out which one of these numbers will go evenly into another number. Square root of 49. Okay, of course, since we don't see a number there for the index, that number here is considered to be a 2 right here, even though you don't see it. So square root of 49 is 49 a perfect square? It actually is. So the answer is 7. And since 7 squared equals 49. Alright, let's move on to another one. Negative square root of 81. Okay, notice there is a negative on the outside here. So the square root symbol is not affecting the negative. So the negative is on the outside. What is the square root of 81? 81 is indeed a perfect square. So the answer is -9 because we have the negative on the outside, but the square root of 81 is 9. So when we put them together, the answer is -9. Let's try the cube root of negative 125. Can we find a cube root of negative 125? Is there a number that multiplied times itself will give you negative 125? Can we find a cube root of a negative number? It turns out you can find the odd roots of negative numbers, but you can't find the even roots of the negative numbers until we get into the complex number system, and that goes off into imaginary numbers. So for this class, yes, we are able to compute the odd root of a negative number, but we're not going to find the even roots of negative numbers. So what do you think the answer is here? Since this is 3, that's an odd number. Yes, it's a negative 5, since negative 5 cubed is negative 125. So yes, negative 5 times negative 5 times negative 5 does give us negative 125. So we can definitely find the perfect cube of a negative number. Alright, let's continue. Let's try the fourth root of 16 to the 4th. Okay, this is actually a property that a law, if you learn it, it will make life so much simpler. So if you have this number right here and this number right here are the same, then it turns out, if you don't have a negative or something right here, it turns out that your answer is this number right here. Alright, so the answer is just the big number, which is 16. And you can always try it the long way. You can say, okay, the fourth root of 16 to the 4th, what is 16 to the 4th? And you can put in your calculator and you would get 16. But if you just know, okay, this number, this is the same. Technically, the answers, when this is even, these are even numbers, is the absolute value of that number, technically. But what's the absolute value of 16? Is 16. Okay. So likewise, if you have, for example, the fourth root of negative 16 to the 4th power, technically the answer is the absolute value of negative 16, which is positive 16. But these are rare cases. You hardly ever see this case right here when it's negative 16 to the 4th. Okay? Because we know negative 16 to the 4th, that's a positive number, right? So our answer will be positive. It won't be negative. So you gotta just make sure you're careful about a situation like this one. Alright, what about the square root of 48? Now, 48 is not a perfect square. And the reason why I'm thinking about perfect squares is because this is the square root symbol. Again, the number that's considered to be here is a 2. But the objective is to get all the perfect square factors out of 48. And yes, there is a perfect square factor in 48. It turns out that 16 is the largest perfect square. So we break 48 up into 16 times 3. Alright, 16 times 3 is 48. And then we can break up these two factors as the square root of 16 times the square root of 3. Alright, now the square root of 16 is 4. And we keep the square root of 3 since 3 is not a perfect square. It stays under the radical. Alright, next we have 5 times the square root of 32. So that's 5 times the square root of 32. So we have 5 times Alright, how can we break 32 up? Okay, 16 is the perfect square there, so 16 times 2. We can break up 5 times the square root of 16 times the square root of 2. And then we have 5 times 4 times the square root of 2. So the answer is 20 square root of 2. So when students see fractions, they get, I don't know, they tense up with fractions. But the rules stay the same. It doesn't change based on a fraction. You just have to apply fraction rules. Okay, so 1/3 times the square root of 90. So 1/3, with our objective is still to break down 90. Can you think of a perfect square in 90? So in this case, you need to have a list always by your side when you're doing this homework, so you can refer to that list of perfect squares and go down that list. 1, 4, 9. I know that 9 goes in 90. So 9 times 10, and it's the largest perfect square because I know I can't break down 10. Okay, if I could have broken down 10 as well, I know that I did not choose the largest perfect square. So we have 1/3 times the square root of 9 times the square root of 10, and we can break down the square root of 9 because the square root of 9 is 3. Now 1/3 times 3, we're going to have to simplify this part. 1/3 times 3, of course we know that 3 is 3 over 1. How do you multiply fractions? You can multiply straight across, unless you like canceling like me. I like canceling things out. So if something in the numerator has a common factor with something in the denominator, then we can cancel. So I know all of this cancels, so it's really a 1 outside. So the final answer is the square root of 10 because it's 1 times the square root of 10. Square root of 22 over 9. Now looking at 22, I know that 22 is not divisible by 9, so I can't do it that way. And the only other way I can think of is I can split up this one radical into 2 radicals. Alright, the square root of 22 divided by 9 is the square root of 22 divided by 3. And that's actually the final answer because there are no perfect squares in 22. There's also a rule that I have to get radicals out of the denominator, and now we have just satisfied that rule because there are no radicals in the denominator now. Here, this is considered to be a radical in the numerator and denominator. Alright, the square root of 24 divided by 49. Again, 24, 49. You can't reduce that, so let's go ahead and split. I like going ahead and splitting it up. Okay, I see that the square root of 49 is 7, so we're done with that. However, the square root of 24, does 24 contain a perfect square factor? Yes, it does. What is it? It is 4. So 4 times 6. Now I can break up the radical in the numerator as the square root of 4 times the square root of 6, all divided by 7, which equals to 2 radical 6 over 7. So now you have to switch your thinking to perfect cubes, and you need to refer back to your perfect cubes list. So what perfect cube is a factor of 16? Okay, a lot of people say 4, but 4 is not a perfect cube. It's a perfect square. So again, switch your thinking to perfect cubes. The perfect cube factor is 8. 8 times 2 is 16. So you can split this up as the cube root of 8 times the cube root of 2. The cube root of 8 is 2. And of course, we cannot simplify cube root of 2 any further, so it stays under the radical. What about 2 times the cube root of 81? So we have 2 times the cube root of 81. Now, what perfect cube factor goes in 81? So we see that 8 does not go in 81. What's the next perfect cube? Does 27 go into 81? So you need to take out your calculator and just figure out, is 81 divisible by 27? It is. So it's 27 times 3 is 81. Then of course you can split this up as 2 times the cube root of 27 times the cube root of 3. You have 2 times cube root of 27 is 3 times 3 times the cube root of 3. Now you can simplify. 2 times 3 is 6. And we keep the cube root of 3.